All right, let's dive in. Today, we're tackling protons.
Okay.
Now, protons, physics might sound a bit,
Yeah.
heavy, but stick with me.
Okay.
This isn't your typical physics lecture. We're talking about cracking codes,
Right.
codes that help us understand the universe.
Yeah, those tiny building blocks of, well, everything.
Exactly.
Yeah.
And there's some really cool new discoveries happening.
Yeah, really interesting stuff.
We're basically peering right into the heart of matter,
It's pretty amazing.
our source for this deep dive.
Yeah.
It's a really fascinating article from SciTech Daily.
Okay.
It's called Cracking the Proton Code, Unveiling the Secrets of the Universe's Building Blocks.
I like that title.
Right. It was published just a couple of days ago.
Oh, very recent.
December 2nd, 2024.
Okay.
And the title, let me tell you, it's spot on.
Yeah.
In this deep dive, we're going to unpack what protons actually are,
Right.
how scientists are actually studying them,
Okay.
and what these discoveries could mean for, physics as we know it.
The big implications.
Exactly.
It all begins with a theory called quantum chromodynamics.
Oh, yeah, QCD.
QCD for short. Yeah.
I got to admit, when I first saw that
I don't
term,
know, it's a mouthful.
I was like, whoa, okay, this is going to be a tough one.
Yeah.
But
then you get into it.
I started digging in, and I realized just how mind-blowing this theory is.
It's pretty amazing.
So could you break it down for us?
Yeah, sure. So QCD, it's the theory that explains the strong force.
Okay.
And that's the force that binds together even tinier particles,
Okay.
quarks and gluons,
Yeah.
to form, protons.
Protons, right?
And what's super interesting is that QCD
Yeah.
suggests that even seemingly empty space, like the space around us,
Right.
isn't truly empty.
Oh, wow.
It's actually teeming with these, virtual particles popping in and out of existence.
Wow, that's crazy.
And that has, huge implications for our understanding of everything, from
Right.
gravity to, the universe's expansion.
Oh, okay. So
Yeah.
it's powerful, right? This QCD,
Absolutely.
Yeah.
But there's, puzzles, too.
yeah, there's some mysteries,
Yeah,
right?
yeah. So we know that quarks and gluons make up protons, right?
Right.
But QCD is so complex,
Yeah.
it makes it really hard to actually grasp how they arrange themselves, how they interact,
Okay.
and ultimately how all of that creates the properties we see in a proton.
So it's like we have the pieces,
Yeah,
but we don't know how they fit together.
exactly. It's like having all the puzzle pieces, but not the picture on the box.
Right.
And to make things even more complex,
Oh, no.
we have these virtual quarks and gluons constantly popping in and out of existence
Right.
within the proton because of quantum fluctuations.
So it's like a constantly shifting.
It's, constantly changing. So it really makes you wonder, what even defines a proton
Yeah.
if its components are always changing?
It's like, what is even real?
I know, right?
Okay, so we have these amazing theories, right,
Yeah.
about protons. But how do scientists actually test them? How do they
It's a good question.
study these things?
So they do it in a pretty dramatic way.
Okay.
They use these giant machines called particle accelerators
Yeah.
to smash particles together at super high speeds.
Like a demolition derby
Yeah, kind of, but on a subatomic scale.
on a tiny, tiny scale.
Exactly.
Yeah.
The article mentions these facilities, like the Thomas Jefferson National Accelerator Facility
Okay.
and the Relativistic Heavy Ion Collider.
Wow.
And by looking at, analyzing the patterns
Yeah.
of the particles that come out of these collisions,
Right.
scientists can actually get clues about the structure of the protons that they smashed.
So it's like, I don't know, smashing two watches together
Okay, good.
and then studying all the little gears and springs
Yeah,
to see how they fit together.
that's a great analogy.
Yeah.
Yeah.
Okay. And this is where things get really interesting.
Oh, yeah.
The article highlights this recent breakthrough. Scientists have found a more reliable way to connect the theoretical framework of QCD
Okay.
with the experimental data from these particle collisions.
That's huge.
It's like they found the Rosetta Stone
Yeah.
for protons.
Right. Exactly.
So this must have huge implications, right?
Absolutely. Now scientists can be more confident
Okay.
in their interpretations of the data,
Okay.
and they can ask more focused questions.
Right, because now they can understand the data.
Exactly. This opens up a whole new world of research possibilities.
And what are some of the key areas of focus right now in this proton research?
Well, a big focus is mapping out the bound state distributions of those quarks and gluons within the proton.
Right.
So imagine trying to understand a ballet.
Okay.
You wouldn't just want to know who the dancers are.
Yeah.
You'd want to know, like, where they are, how they're moving.
Your positions, their motion.
Exactly. And how it all creates the overall flow of the performance.
So we're not just identifying the dancers. We're trying to understand the whole choreography.
Precisely. Scientists are, like, creating detailed maps of the motion of quarks and gluons inside the proton.
Right.
Understanding how they're bound together and how their movements, contribute to the properties of the proton as a whole.
Like spin, mass, that kind of thing.
Exactly. Spin and mass, those are big ones.
And why should we care about those things? Like the spin or mass of a proton?
It seems tiny.
It seems so tiny, right?
Yeah.
How could that possibly matter?
Well, it turns out these tiny details have these massive effects on the behavior of matter at all scales.
Okay.
So the properties of protons affect everything.
Wow.
From how atoms form to how stars burn.
So it's like the tiny things affecting the big things.
Yeah, it shapes the universe as we know it.
Wow. Okay. I'm starting to see why this is such a big deal.
Yeah.
We're not just talking about one tiny particle.
Right.
We're talking about like the fundamental forces that make up reality. That's incredible.
And that's why this breakthrough is so important.
Yeah.
Because it brings us one step closer to understanding those forces.
But like any great mystery, there's got to be some twists and turns, right?
Absolutely.
Like what are some of the challenges?
Yeah. So the article points out this long-standing problem that's been puzzling scientists.
Right.
There have been these inconsistencies in how they were combining the predictions of QCD with the experimental data they were getting from the particle collisions.
So it's like their map wasn't quite matching up.
Exactly. It's like having a map where the landmarks don't line up.
You get lost.
You would get so lost.
Yeah.
But the good news is that these new theoretical results are like finally having a GPS that works.
Okay.
They give us a much clearer way to interpret the data.
That's great. So now they have a better tool.
Yeah, a much better tool.
All right. This is incredible.
Yeah, it's pretty amazing.
We covered so much.
I know, right?
We started with this mind-bending world of QCD.
Yeah.
These massive particle smashers.
Those are pretty cool.
These breakthroughs that are allowing scientists to look inside the proton.
Yeah, to peek right into the heart of it.
But this is just the start, right?
Oh, yeah, there's so much more to explore.
There's so much more to this story.
Absolutely.
Welcome back. I'm still thinking about the proton. It's amazing to think these tiny particles are like the foundation of everything.
Right, everything we see and touch.
But they follow these rules that just seem, I don't know.
Kind of magical, almost.
Yeah, and we're just starting to understand it all.
Just scratching the surface.
Right. Before we jumped into part 2, we were talking about how scientists are mapping those movements of quarks and gluons.
Right, inside the proton.
Like choreographing a subatomic ballet.
It is. It's like a delicate dance.
Yeah. But how do they even measure something like a proton's spin? I mean, it's so tiny.
Yeah, well, that's where those incredible particle accelerators come in.
Oh, right, the smashers.
Exactly. They smash particles together at those incredible speeds, and by carefully studying, like, analyzing the debris from the collisions, they can actually figure out information about the original particles.
So they can, like, work backwards?
Yeah, kind of. It's like a puzzle.
Okay.
Each collision gives them a little piece of information.
Got it. And the article mentioned this new facility.
Oh, yeah.
The Electron-Ion Collider.
The EIC.
EIC, right. What makes it so special?
So previous colliders weren't really ideal for studying proton spin.
Okay.
But the EIC is specifically designed to collide electrons and protons.
Okay.
And this is key because those collisions are much more sensitive to the spin of the proton.
So it's like the right tool for the job.
Exactly. It's going to give scientists a way clearer picture of what's going on inside the proton.
Wow. And it's not just spin, right?
No, not just spin. The EIC will also help us understand how mass is distributed within the proton.
Wait, hold on. Don't we already know the mass of a proton?
We do.
It's constant, right? Right.
Yeah, but it's not that simple.
Okay.
The mass of a proton isn't just the mass of its quarks added up.
Oh, okay.
There's also a contribution from the energy of the strong force, which is, described by QCD.
So, like, the mass of a brick house isn't just the bricks. It's also the mortar holding it all together.
Perfect analogy. And that mortar, in the case of the proton, is that strong force governed by QCD.
Right. Okay.
So The EIC will help us map out how that mass and energy are distributed.
Wow.
Shedding light on how QCD actually works.
This is, like, we're not just mapping a particle.
Right.
We're mapping, like, the fundamental forces of the universe.
Exactly. That's what makes it so exciting.
Yeah, yeah. Now, we talked before about those inconsistencies.
Oh, right.
Between the theoretical predictions of QCD and the data from experiments. It sounds like scientists were dealing with a map that, like, didn't match up with reality.
It was a confusing time, for sure. But those new theoretical results we discussed?
Yeah, the breakthroughs.
Yeah, those are helping a lot. It's like finally having that reliable GPS.
To guide us through the proton.
Exactly.
So those breakthroughs are, like, paving the way for even more discoveries.
Absolutely. They're essential, especially as we move towards those complex experiments like the EIC.
It feels like we're on the verge of, like, really cracking the proton code.
I think we are getting closer.
But there's always more, right?
Oh, definitely. The proton is incredibly complex.
Yeah.
We're just starting to understand it.
It's like setting sail into uncharted territory.
Yeah, a whole new world to explore.
Exactly. And we don't even know what we'll find.
The possibilities are endless.
But it's that excitement, right?
Absolutely. The thrill of discovery, the desire to understand the unknown.
What drives us.
And who knows what we'll find. The insights we gain could change everything.
Yeah, impact how we understand the universe.
From the tiniest particles to the largest structures.
Wow. This has been, like, seriously mind-blowing.
It's been a great discussion.
We've covered so much ground, but it feels like there's so much more.
There's always more to explore.
Right. Welcome back to the Deep Dive.
It's crazy to think we started with these tiny particles, protons.
Yeah.
And now we're, like, talking about the nature of reality itself.
And I know, it's amazing.
It shows you how even the smallest things can have the biggest mysteries.
It really highlights how everything is connected in the universe.
Yeah.
When we study something as fundamental as a proton, we're not just learning about a single particle.
Right.
We're learning about the fabric of reality. Before we finish up, I want to go back to something that's been on my mind.
Okay.
We've talked about how protons are made of these even tinier particles.
Right. Quarks and gluons.
Right. And they're always moving, even popping in and out of existence.
Yeah, it's pretty wild.
So if that's true, how solid is anything, really?
That's a question that's puzzled people for centuries.
I know. It's like it makes you question everything.
It challenges how we think about the world.
Exactly. Like, what if everything we see is just an illusion?
It's definitely a shift in perspective.
Yeah.
Quantum mechanics can be really counterintuitive.
Right.
It forces us to rethink what we thought was possible.
Like the ground beneath our feet?
Yeah.
It's not really solid?
It's just this, like, constant dance of energy and interactions.
Wow, that's mind-boggling.
It is, but it's also pretty exciting.
It is. It makes you realize there's so much more to the universe
than we can even imagine.
Than we can even see.
Exactly.
So where do we go from here? What's next for proton research?
Well, one of the biggest mysteries is still the origin of the proton's spin.
The spin, right?
Yeah. We know quarks and gluons have spin, but their spins don't add up to the total spin of the proton.
So where does the rest of the spin come from?
Exactly. That's what we're trying to figure out.
It's like those missing socks in the laundry.
I like that analogy.
They have to be somewhere.
Right. And that's just one of the many puzzles we're working on.
Yeah, like those virtual quarks and gluons.
Right. We're still trying to understand their role.
They're important, but we don't know exactly how.
It's a work in progress.
And with that new electron-ion collider.
Oh, yeah. The EIC.
I feel like we're about to learn so much more.
It's going to be a game changer.
It's going to revolutionize proton research.
Absolutely. The EIC will let us test our theories with incredible precision.
And maybe finally answer some of these big questions.
We can hope.
Every new thing we learn about the proton, it's like it changes how we see the whole universe.
It's a reminder that even the smallest things can have huge impacts.
Well, on that note, I think it's time to wrap up our deep dive into the proton code.
It's been a great journey.
Thanks for joining us.
It was a pleasure exploring these ideas with you.
And remember, the quest for knowledge never ends.
Keep asking questions.
Stay curious.
And never stop exploring the universe.
Until next time on the deep dive, keep those brains buzzing.